It is only in this 20th century that man has mastered the secrets of powered flight, an ambition that was a dream for thousands of years. This airplane, designed in the early 16th century by Leonardo da Vinci, was to be powered by flapping the wings like a bird. He also designed this aerial screw, which is similar to our present-day helicopter. Nearly 400 years later, the first heavier-than-air machine was flown. In 1903, at Kitty Hawk, North Carolina, Wilbur and Orville Wright succeeded in fulfilling man's age-old dream. The Wright brothers were pioneers in the science we call aerodynamics. Today, aerodynamics is an important science. Aerodynamics is the study of the motion of air, or the motion of an object through the air. These aeronautical engineers are specialists in the branch of aerodynamics that deals with principles of flight. In studying aerodynamics, scientists are concerned with 4 forces that act on all airplanes. These forces are lift, thrust, gravity, and drag. We can learn something about how these forces act by observing this kite. Notice how the kite is moving against the wind. It is designed so that the wind hits it at an angle. Because of the angle between the kite and the wind, the kite deflects or pushes the wind downward. At the same time that the kite pushes the air down, the air pushes the kite up. All of this happens simply because the kite travels through the air at an angle, like an inclined plane. We can think of an airplane wing as an inclined plane, too, but a specially shaped inclined plane. The wing is designed so that the air moves past it, thus the word airplane. Engineers call this specially shaped inclined plane an airfoil. This airfoil, or wing as it is more commonly called, is designed to move through the air at an angle, somewhat like the kite. This angle is called the angle of attack. Because the wing does meet the air at an angle, the air beneath the wing is pushed downward. The air also pushes the wing up, as it did with the kite. This upward pushing force gives the wing about 1/3 of its lift. The rest of the wing's lift comes from the special shape of the wing. When this wing moves through the air, the special shape splits the air into 2 streams. We saw that part of the lift comes from the air that passes beneath the wing. A second stream of air passes over the top of the wing. But because of the curved shape of the top of the wing, the air that goes over the top has a greater distance to travel. Yet, as we see, both streams of air reach the back of the wing at the same time. This happens because the air that goes over the top of the wing moves faster than the air that goes under the wing. The faster stream of air above the wing exerts less pressure. The greater pressure below the wing pushes the wing up toward the lesser pressure. This difference in air pressure accounts for 2/3 of the wing's lift. Remember that we said that the wing gets lift by moving rapidly through the air. This huge airliner flies through the air because of lift that comes from its wing. This is a wing, too, even though it does not look like the usual airplane wing. The helicopter's wing, called a rotary wing, is moved through the air by spinning it rapidly. The air streaming over the rotary wing creates the force called lift. This lifting force makes the helicopter go up, but by tilting the rotary wing, as we see in this exaggerated example, the pilot can also make the helicopter go forward, or in any other direction that he wishes. Now, in addition to the force of lift, the rotor is providing another force, thrust. Thrust makes the helicopter go forward. What would happen if we were to tilt the rotor even more? Now the only force the rotor is providing is thrust. In conventional airplanes, thrust does not come from a rotor, but from a propeller, like this one. The propeller works on the same principle as the rotary wing that we just saw. The propeller provides the thrust that makes the airplane go forward. The greater the thrust, the greater the forward speed. Thrust, in one form or another, is necessary to make any airplane move through the air. Now our airplane is flying. Two forces are making it fly: the lift produced by the wing and the thrust produced by the propeller. Remember that the propeller creates a forward force in the same way that the wing creates lift. Although these two forces make flight possible, they are constantly being opposed by other forces. One of these forces is gravity. Gravity is always pulling the airplane back towards the earth. Drag is the other force working against the airplane. Drag is another name for air resistance. Drag slows down the airplane. When lift equals gravity, or the weight of the airplane, thrust is equal to drag, the airplane is said to be flying straight and level at a uniform speed. The forces of lift, thrust, and drag are constantly changing. By moving different controls in the cockpit, the pilot changes the effect of the forces on the airplane. When the pilot moves these controls, he also moves certain surfaces located on the airplane. These surfaces, for example, are the ailerons located on the wings. They are moved by turning the control wheel to the right or left. On the floor of the cockpit are two pedals that the pilot pushes to operate the airplane's rudder. The pilot can also control the action of the airplane's elevators. Like the rudder, the elevators are part of the tail assembly of the airplane. When one of these surfaces is moved, the air striking it develops a force which makes the airplane move in a different direction. For instance, if the elevators are raised, the airstream now pushes against them. This makes the tail go down. It also makes the nose go up, and the airplane starts to climb. In making the airplane climb, or turn, or perform any other maneuver, the pilot has to move at least two controls at the same time. For example, when he turns the control wheel to the right, and at the same time pushes down on the right rudder pedal, the airplane turns to the right. This dual control movement is called coordination. Coordination is necessary because there are four forces acting on the airplane. Can you remember what the four forces are? Lift is the first force that we learned about. Part of the lift is caused because the wing meets the air at an angle of attack. This pushes the air down. At the same time, the air pushes the wing up. The rest of the lift comes from the shape of the wing, which reduces the air pressure above the wing. The greater air pressure below the wing also pushes the wing up. The second force is thrust. The thrust on the airplane we have been watching was made by a propeller. But thrust can be made in other ways. For example, jet airplanes get their thrust from hot gases that are forced out of the tailpipe. The third force that we learned about was the force of gravity. Gravity is always pulling the airplane back toward the earth. Drag, or the resistance of the air, is the fourth force acting on the airplane. We also learned that the pilot controls the movement of the airplane by controlling the differences between these forces. Understanding these principles of flight will help us understand how all airplanes fly and change direction. In fact, the forces of lift, gravity, thrust, and drag help to explain how all airplanes fly in the Earth's atmosphere.